Hello and welcome back to another video. In this problem, we're told that a function f has domain -5, 5, and a portion of its graph is shown. First, we're asked to complete the graph of f if it is known that f is even. If f is even, that means that f of x is equal to f of -x. What does that mean? That means for every point here, there's a point on the other side of the y-axis with the same value, right? That is, it is symmetric about the y-axis. So if we have these points here increasing in value very quickly on this side, the same thing happens on this side. Then there's these points that are relatively constant, but dipping a little bit here. The same thing has to be reflected on the other side. And you can see how the shape is reflected, and you can sort of finish the graph. And you know that you have the right graph if for any point, let's say here, on one side, there's a point equally far from the y-axis on the other side with the same y value. Perfectly matches. For B, that was for A. For B, if f is odd, that means that f of x is equal to -f of -x. That means for any point on this side, there is the same point on the other side, just flipped. So if there's this point here with a relatively high y value, pretty close to the origin, there is a point with a very high negative value close to the origin. So the graph reflects the shape of the graph on this side, it's just upside down. This is symmetric about the origin, is what we call it. You can see that these two graphs, or these three graphs, these three sections, the original, the part in A, and the part in B, all have the same shape. It's not perfect because it's hand-drawn, but they're just reflected over either the y-axis or the origin.